In this lesson, we will review the power rule of derivatives. But let's first review some basic rules. The derivative of a constant. What is the derivative of any constant? The derivative of any constant equals 0. So if that's true, what is the derivative of 3? The derivative of 3 equals 0 because 3 is a constant. What is the derivative of -5? The derivative of -5 equals 0 because -5 is a constant. What is the derivative of pi? The derivative of pi, because pi is a constant, equals 0. What is the derivative of e? We know e is a constant, so the derivative of e equals 0. Now, both pi and e are irrational numbers. Irrational means they do not have finite digits. Their digit extensions go on forever. But even though they are irrational, they are constants, so their derivative equals 0. So the derivative of a constant equals 0. But how about if we're multiplying that constant times a function? So let's look at that. d dx, the derivative of a constant times f of x. So the derivative of a constant times a function is the same as that constant times d dx of f of x. Let's look at specific examples. So d dx of 2x squared. So first we identify the constant. So the constant is 2. And then we isolate it. So we will have 2 times d dx x squared. So those two are equivalent. So let's try another. So the derivative of 1/2 x to the third. So we find the constant. So the constant is 1/2. And then we put it in front before the differentiation. So it is 1/2 df dx, or d dx x cubed. Okay, let's solve another. So d dx of -3 x to the 6. So let's isolate the constant. The constant is -3. So -3 d dx of x to the 6th. Let's try one a little different. So d dx, the derivative of 2x over 5. So when we look at this, what is the constant? So we can isolate 2/5. So 2/5 times d dx of x. So both of those on either side of the equation are equivalent. And let's try one more of these. So d dx of negative 5x over 2. So identify the constant. The constant is negative 5/2. So we write that. D dx. So f of x is simply x. Very good. We quickly reviewed the constant rule and the constant multiple rule. But now we're going to learn the power rule. The power rule is d dx of x to the n power equals nx to the n minus 1. And we'll do some specific examples. D dx, x to the third power. So the power rule says that the derivative of x to the third power, we take the exponent, put it in the front, 3x to the 3 minus 1 power, which is the same as 3x squared. We'll try another. D dx of x to the 5th take the exponent, put it in the front, 5x to the 5 minus 1 equals 5x to the 4th power. Next, d dx to the x to the 7th power. Put the exponent in the front, 7x to the 7 minus 1 power equals 7x to the 6th power. D dx x to the 9th power. Put the 9 in the front, 9x to the 9 minus 1 equals 9x to the 8th power. So this is what we call the power rule. Now let's try some other examples of the power rule. Let's combine the constant multiple rule with the power rule. So d dx to x to the 4th power. Now we're going to apply the constant multiple rule, isolating the constant. So equals 2 times d dx of x to the 4th. And now we're going to apply the product rule. So equals 2 times, and then 4x to the 4 minus 1 equals 8x to the third power. Let's try another. D dx 3x to the fifth. So we apply the constant multiple rule, equals 3 times d dx x to the fifth. And now we apply the product rule, equals 3 times 5x to the 5 minus 1, which equals 15x to the fourth power. Let's try another. D dx 4x to the sixth power. Isolate the constant. 4 times d dx x to the sixth. Apply product rule, equals 4 times 6x to the 6 minus 1 equals 24x to the fifth power. Let's try another. D dx 5x to the seventh. What's the next step? The next step is to isolate the constant. So equals 5 times d dx x to the seventh. Now what do? We apply the product rule, equals 5 times 7x to the 7 minus 1. And that equals 35x to the sixth power. Let's find the derivative of functions with negative exponents. F of x equals 1 over x cubed, which is the same as x to the negative third. And we can plug this into the power rule. So f prime of x equals negative 3 x to the negative 3 minus 1 equals negative 3x to the negative fourth. And then to get rid of the negative exponent, equals negative 3 over x to the fourth. Let's try another. So f of x equals 3 over x squared equals 3x to the negative 2. So we can plug this into the power rule. F prime of x equals 3 times negative 2x minus 2 minus 1 power, and that equals negative 6x to the negative third power. To get rid of the negative exponent equals negative 6 over x cubed. That's the final answer. Next, f of x equals 11 over x to the fifth equals 11x to the minus fifth. Okay, we first identify the constant, isolate the constant, and then we apply the power rule. So f prime of x equals 11, which is the constant, times negative 5 x to the minus 5 minus 1. So we've applied the power rule. Then when we multiply that out, we have negative 55 x to the minus 6 equals, then we get rid of the negative exponent, so it's negative 55 over x to the 6. And then one more. So fx equals 17 x to the third equals 17x to the negative third. Apply the constant multiple rule. F prime x equals 17. So we've isolated the constant, and now we're going to apply the product, the power rule, minus 3x minus 3 minus 1. So there we've applied the power rule, and now we multiply it all out, equals negative 51 x to the minus 4. Now we get rid of the negative exponent, so we have negative 51 over x to the fourth. Very good. Let's find the derivatives of polynomials. So we'll start out with x to the third minus 2x squared plus 5x plus 9. And using the power rule, we have 3x to the 3 minus 1 minus 2, and then we have 2x to the 2 minus 1 power, and then we have plus 5, and this is x to the first power, so it would be 1x to the 1 minus 1, which is 0. So x, anything to the 0 power is 1. So we basically have a 5, and then plus 9, and it's 9 times x. It would be x to the 0, so it would be times 0 x to the negative 1. Anything times 0 would be 0, so this crosses out. So we end up with 3x squared minus 4x to the first power, so just 4x, plus, and then it's 5x to the 0, so 5, and then the next number was simply 0. So this is our final answer. Okay, let's do another. So 2x cubed plus 5x squared plus 3x plus 11. So we use the constant multiple rule. So we have 2 and then 3x to the 3 minus 1 power plus 5 and then 2x to the 2 minus 1 power plus then 3 times, so it's x to the first power, so it would be 1x to the 1 minus 1 power, and then it would be 11 times 0, so we would cross that out. So we end up with 6x squared plus 10x to the first power, so it's just 10x plus 3. That's the final answer. Okay, let's try one more. So 7x cubed plus 3x squared plus 17x plus 101. So using the constant multiple rule, 7, and then using the power rule, 3x to the 3 minus 1 plus 3 times 2x to the 2 minus 1 plus 17. So it's to the, this is to the first power, so it would be 17 to the 0 power, which is 1, so it's simply 17, and then the 101 crosses out. So we end up with 21x squared plus 6x, simply 6x plus 17. And that is the final answer. I really enjoyed making this video about the power rule of derivatives, and it's very fun. The steps are simple. You just need to be very methodical and systematic in your answers, like most of calculus. It's not, the concepts are not that difficult, but you have to be very, very careful in your calculations. Thank you very much. Bye.